Okay, example number 2, we're going to be solving and we want to give the exact answer. And one of the things that we need to note is if I gave you something like this, and hopefully you'll get pretty quick at this, 4x equals 0, what number could we choose that would make this statement true? So if I pick 2 in here, 4 times 2 is 8. Well, 8 doesn't equal 0. And so it should be pretty obvious that the number that we would have to choose for x would be 0. Because 4 times 0 equals 0. Sometimes you get things like this. 4xy equals 0. And it's one of those things that says, okay, well, how can we make this statement true? Well, if I make x to be 0, I've got 4 times 0 times y equals 0. Y can be any number we want. It could be 15. And we would get a true statement, because 4 times 15 is 60, and 60 times 0 is still 0. So the fact that we make this x, the fact that we choose this to be 0, makes the whole thing 0. I could pick this y to be 1,000,000. And 0 times 1,000,000 times 4 would still be 0. At the same time, I could choose y to be 0. So instead of writing y, I can make that 0. And I could choose x. X could be 15. 4 times 15 is 60. 60 times 0 equals 0. 0 equals 0. That makes a true statement. So the idea is, if you have two things, and it has to equal 0, if we have two things, we can make x 0 or we can make y 0. And it doesn't matter which one we can make. If we make y 0, we can make x 1,000,000, and that would still be 0. If you make x 0, you can make y 15 trillion. It would still make the whole thing 0. And that only works because these are timesing. And that works really well for what we're about to do now. And that's what this is trying to say. If you have two things that multiply to equal 0, so if a times b equals 0, then we can make the a 0, because 0 times a billion, if b was a billion, 0 times a billion is still 0. Or we can make the b 0 and say a was 15 gazillion. 15 gazillion times b being 0 still is 0. And so that's the idea. Either of these can be 0. And we're going to use that when it comes to something like example 2. So example 2, it wants us to solve. And we've got an x squared and we have an x. And the idea is you need to find out what x equals. Now in the previous questions, in all of these first ones, I only had a single x. There's an x. There's an x. There's an x. There's an x. This example 2 was odd because I had an x and an x. But I could get them onto one side. Remember, I minus the 2x over to get a 13x. So I could get all the x's and I could combine like terms. But all of them only had x's. And if I look down here, I only had x squared. I didn't have an x squared and an x. Here I only had an x cubed. Here I only had an x squared. But now I have an x squared and an x. And I can tell you right now, they are not like terms. There is no way that we can combine them. So the only way to solve this is to factor. So what do we have on the left? X squared. X times x gets me x squared. What about the right? I need to multiply to the right side. So remember, this is the left. This is the right. So I need to multiply to 21. I don't know. 7 times 3. And I need to make one of them negative. Okay, negative 7. And then when you do that, you're going to factor. So like the whole unit's been factoring. So this diagonal is 3x. This diagonal is negative 7x. If you add them, you get negative 4x. Is that my middle term? Nope. It's close. It's a positive 4x. So that means I need to change my signs. So this negative 7 here, I'll make it a positive 7. And this positive 3, I will make a negative 3. So my diagonal is negative 3x and positive 7x. And if you add those, I get a positive 4x, which is exactly what I want. So remember, that's just me factoring. So I've got an x plus a 7, and I have an x minus a 3. And there's an equal sign. Equals 0. And this is the part where we're using that timesing rule. So we're saying if this left side is 0, 0 times anything will be 0. Or if the right side is 0, 0 times anything is 0. So we do this little thing here. I split it up. I say, hey, x plus 7, that's this one, that can be 0. Or we can choose the other side, which is an x minus 3. That can equal 0. And so let's do this here. These are two separate questions now. Minus 7 and minus 7 gets the x alone. So then x is equal to negative 7. And plus 3, x is equal to 3. So those are our two answers, apparently. So if you tried, and you don't have to do this, but if you put a 3 in here, 3 squared would get me 9. And if I put a 3 in here, that 3 times 4 would get me 12. And there's a minus 21. So 9 plus 12 is 21 minus 21. 21 minus 21 is 0. And sure enough, that makes my thing true. So it's apparently putting a 3 in there works. Let's try negative 7. Negative 7 squared, negative 7 times negative 7 is positive 49. 4 times negative 7 is negative 28, and I've got a negative 21 there. Those can be combined to be a negative 49, and this carries down. 49 minus 49 is indeed 0. So that works as well. So both of these work. You don't have to check. They will just always work, assuming you factored correctly. So the idea here is, would you have ever guessed that negative 7 could go into both of those and get you 0? Probably not. Maybe you would have guessed 3, but that's a hard thing to do. So what do we do instead? Well, you factor. And then, once you factor, you use the rule that says either this could be 0, so x plus 7 equals 0, or x minus 3 can be 0, and then you just solve two little kind of grade 8 questions here, two little algebra expressions or equations, and you get your two answers. So I realize that we're moving pretty fast here. I am going to show you the next one, stop the video, and then I'll do some more in the next video. This only works if you set the equation equal to 0. So the very first thing I need to do is minus this 12 from both sides. So that's gone. I get a 0. And on this side, I have 2x squared plus 5x minus 12. The 12 it's not a like term, it can't be combined. Okay, let's try to factor this thing. The left side, x and x, needs to be a 2 and a 1. So 2x and 1x get me 2x squared. The other side needs to be 12. I don't know, 4 and 3. One of them has to be negative. I don't know, like that. So then I got negative 8x, positive 3x. That gets me negative 5x. That's not what I want. I want positive 5x. So that's easy enough. I can just change this to a minus 3 and a plus 4. Now my diagonals are 8x and minus 3x, which get me 5x, and that's what I need. So I'm just going to erase that here. I don't need to show the 8x, and 3x, and 5x. So I've got 2x minus 3 and 1x plus 4, which I'll just write as x plus 4, equals 0. So then I can create two equations. 2x minus 3 equals 0, or x plus 4 equals 0. I'll do this one first. I'll minus the 4 from both sides. So x is equal to negative 4. So that's one of my answers. I have solved for x. X has to be negative 4. And the second one, I'll add 3. 2x is equal to 3. And then I'll divide by 2, and I've run out of room, but x is equal to 3 over 2. That is my other answer. So I've solved that. You should probably take out the notes and that I've already provided and take a look at some nicer, cleaner versions. I will, how many more do I have? 1, 2, 3, 4, 5, 6, and then those ones. Ugh. Beautiful. So I'll do the next 5 in the next video here. You should probably at least try to do C on your own right now, and then watch my next video to see how that works.